going on, you guys? Today, well, actually, welcome. If you're here for the first time, go ahead and subscribe to me on YouTube or Twitch or whatever, or Mixer, whatever you're using. It'll really help me out. Today, whenever I go through, I feel like I don't really get to say a whole lot of self-promotion or something whenever I'm trying to program through stuff. So if you're not yet, following me somewhere, please do so. Oh, my hair looks so freaking jacked up right now. I haven't had a haircut in so long, it feels like. I tried to wait to get a haircut even before the lockdown happened, and I'm looking at it on the monitor over here, and I should not have waited. I wish I would have got a haircut right as people were getting locked up, and ugh. Okay, anyways. Today what we're going to do is continue working on the ArduBoy port, the Palm Pilot port of an ArduBoy game called Circuit Dude. I'm going to go back over and show you where we're at in the game, but I also want to show you a little bit about Circuit Dude on ArduBoy first, because what we're going to do today for the first time is really jump into gameplay. We have the levels being drawn, we have the levels stored in a binary file where you can scroll through the levels and see them all, and they're represented pretty similar to how you would see them on the ArduBoy. And I do have some animations already working as well, so we'll take a look at that. We'll also take a look at how it originally works on the ArduBoy, and I'll let you know what we're doing next. Today, let's see. Actually, I wrote some notes down here. Let me see if I can pull those open. Okay, so we're going to do onLeave, onEnter, and swap all, which are three functions that are essential for this kind of game. Circuit Dude is a puzzle game, so we're going to go through and show you where these are relevant. But if you just look at what we have so far in the game, you have Circuit Dude, and you're able to walk around with him. Basically, none of the collision works, and no tiles have any kind of mechanics that are working. And that's because we don't have any kind of events that fire whenever he moves onto a space or when he leaves a space. Normally, he'd fire an event every time he walks onto these little tiles right here. And also, there's something called swap all that we'll need. And swap all will go through the entire level and find all tiles of a certain type and switch it over to another type. So without further ado, let me show you the ArduBoy version of Circuit Dude, which I already have pulled up over here. Let me make this a little bit bigger. There we go. And this is on the ArduBoy forum itself. If you don't know what an ArduBoy looks like, it looks like one of these. It's kind of like a Game Boy, and you can go through and play it. There's 75 levels for this version, and the Palm Pilot version that we're porting, we want to have all those levels and have pretty much exact same compatibility, all the same features, stuff like that. So let's just take a look at the first level here. Maybe? Yeah, there we go. So we can move Circuit Dude around, and as we step onto these sockets, he replaces them with a computer chip. And whenever all the chips are plugged in, you see these lights that appear up here. They basically turn on, and then the exit portal starts animating. Of course, we don't have that animation in, and we don't have the lights lit up either. And when you beat the level, it'll automatically move to the next one, or it'll show you the main menu if you beat it before. So let's go to this level. The main catch with this game is if you for some reason block yourself in and can't get to the exit, you have to blow yourself up, and it restarts the level. So let me beat this level real quick. Eventually the levels get harder, but then more mechanics are introduced that kind of make the game still fun. So these are conveyor belts, and if you step on one, you move automatically to where they're pointing to, and they could be used to move you all around the stage. So the animation for these are put into the Palm Pilot version. If I go to the same level, it's level 6, you can see it right here. So it is animating. Oh no, I'm sorry, that's a different level. This one. It is animating, but of course the lights aren't going to be swapped. The tiles can't be stepped on. The walls look a little different. We're not going to worry about that today. And the exit portal is pretty static whenever you complete all the chips, when you collect all the chips. So what I did between last stream, between last stream and this stream is basically implement these animations. Let me see if I can get the magnifier out. It's a little hard to see this from time to time, so I'll zoom in a little bit. But you can see these tiles are animating. There is some flicker, so there's some optimizations that we can be doing later, but this is a pretty good representation of what it looks like on the ArtiVoy. So that'll work for now. So off the stream, I went ahead and implemented the rest of the animations for these tiles and converted them in Photoshop, as well as a few other files that we'll take a look at later. So to get on enter working and on leave working, that kind of implies that there's a brief moment in time where Circuit Dude is transitioning from one tile to another. If you look here, like he kind of slides, it looks like, between tiles. And so I also want to do that with our work today, so that we can properly show you the on enter and on leave event. So I'm gonna add up here slide between tiles, and that's going to take a little bit of work because right now you can just freely move anytime, anywhere. There's no collision checking, and that also means you can just go outside of the map too, and there can be some errors that pop up as a result of that. So the first thing we're going to do whenever we slide between the tiles, we're going to look at basically a destination. I think I minimized it. All right, we're going to look at our destination tile, and we're also going to look at the tile we're currently at. And also we have to have some sort of counter to move us. Whenever you move, you instantiate a move, you can't for some reason interrupt the move, so we have to be able to handle that as well. So our moving is actually defined currently with, I think it's called input direction. And right now we just have a loop for every single time we have an event. We check to see what it is. If it's a key down event, we check what that key down event is. If it's an arrow, we set input direction to that direction. And then we cycle through direction. Input direction. I know I used this somewhere else. Oh, down here. Yeah, so we cycle through with this gameplay loop and we check to see if it's equal to stay. If it is equal to stay, then we're going to just stay there. If it's not, we're going to do this and actually move. And you see for moving, all it does is it checks to see if you know, where Circuit Dude's current location is, his X and Y location, and then it manipulates that, increases or decreases it. And then it sets the input direction to stay. So instead of input direction being the end all be all for moving Circuit Dude, we also want to figure out where we instantiate those variables and create another one. And let's call this one Dude Moving. And we'll set this one to be a Boolean. And we'll say dude moving equals to false over here whenever we load the level. Now, whenever we do a button to see what happens, we need to actually check to see if we're allowed to move Circuit Dude. So I would normally do something like if dude moving is false, then input direction equals up. I could do that, but there's some other reasons why later on that's not a whole, that doesn't make a whole lot of sense. So whenever it comes to checking for collision and stuff, we don't want to include checking for collision every single location, all of these rows. Instead, what we want to do is have a function or some sort of procedure, and we'll call that one attempt move, or maybe check move. Let's see. Check. Can enter. Yeah, so can enter, can leave. For the Arduboy version, I do check to see if you're allowed to enter or leave. But I think just because of the way this code is written, I want to add those together in this function here, this new one. So it'll slightly deviate from the code that we have for the Arduboy. Let's make this procedure, and we'll call it procedure. Actually, let's just call it move, dude. Move dude, and it'll take an integer, and it's going to be called direction. And begin. And okay. And instead of this dictating input direction, the handle event function will not even know about the input direction. Instead, it'll just say move dude up. Same for these. Now move dude is going to actually handle that. Well, like we said, we also want to include dude moving, or yeah, right? Is that what it's called? Dude moving? Yeah, we also want to include this check too. So if dude moving, no, if not dude moving, then and no. There are a few weird caveats with this language. We're using high-speed Pascal, which is sometimes called HS Pascal. There are a few weird things with it, so I'm just going to run our compiler to make sure it's okay, which it is. It compiles, and now let's install it onto the emulator. And run it. And looks like we can still move like we could. Great. So, dude moving, we have input direction. Perfect. So, down here for gameplay, we say if input direction is stay, then, or if it's not stay, then we're doing this. We're moving him here. But we shouldn't do that. We should use dude moving, right? So if dude moving, okay. So if he's moving, then we're going to do something until he gets done moving, and then we'll say dude moving equals false, and then input direction equals to stay. But there is a thing here. There is an interesting case here where we don't really need that. And the reason being is if somebody's holding down a button, we want that to continue to move Circuit Dude after he stops moving. So we have a continuous continuous movement. And we can actually put that where we call our move dude function. So we're trying to move him, but if we're not putting any of these buttons in, we essentially could do something like this. Input direction equals stay. Before all that, we don't want to call it during handle event, because handle event only fires when we're handling an event. So you can see down here that gameplay is called right after it. So we could actually put this in gameplay itself. Let's see. There we go. I think that should work. There's a roundabout way of saying that we can move it out of this block. So dude moving equals to false. We're going to basically move him. And we could have some sort of counter to figure out where he's at along his movement. And as we're moving him, remember, we're needing to draw the tile that he just moved from, and also draw him where he's going to be. So that's what this part does. We covered that last stream. But now we're at a point where when Circuit Dude moves around, let me blow him up real quick. When Circuit Dude moves around, he actually can be on multiple tiles at a time. So you have to think, what happens if he's on two tiles that have animations behind them? So what we're going to do is redraw both of the tiles the entire time that he's moving between them, so that the animations don't get interrupted. So if we go over here, we can do draw tile map on his current location and draw tile map for his new location. So in case input direction, so this is basically figuring out where he's, like where the new Circuit Dude position is, but we can move that to the move dude function, which should move Circuit Dude instead. So this should be pretty much similar to what we did before, where we set his new location. But like I said, we're sliding him, we're not teleporting him. So let's introduce a new idea. Instead of dude moving be a Boolean, let's make it an integer. And it'll be like the moving timer. It'll be a timer of some sort. So if he's not moving, let's set the timer to 0. And while it's more than 0, then we're counting down to 0 to show that he's moving. So if Circuit Dude is 0, then we should be able to move him. Otherwise, we're going to wait for dude moving to finish. So if dude moving is greater than 0, then we'll actually slide him here in gameplay. Okay, hope that makes sense. Let me know if it doesn't, or if you have some questions. I don't mind people asking questions and stuff in the chat. I know that there's a few people here, so feel free to ask whatever you want. If I'm going too slow, or maybe if I'm going too fast, let me know. So dude moving, if it's greater than 0, then we're going to move him, and we only want to move it until it is 0. So we need to decrease dude by 1 every time that it's more than 0. And since we're moving him with move dude, where's that? Move dude. And we give it we set the input direction here. We also should do this. Dude moving equals to some constant, like 8. But we can define that constant in circuitdude.res. Oh, we have here a map width variable. That was set a while back. We don't really need that. So I'll call this move timer. And dude moving equals move timer. Now, whenever he's moving, we actually want to move his like actual location by 1 pixel, and we could do that. We could normally do that, but if you look here, dude is actually moving by 1 value every single time it gets moved. The truth is that we might not want to do that. Instead of having 1 value be 1 tile, we actually want to know the location on the screen that he is, so he can move between tiles. So kind of like how we have a constant for move timer, we also should have a move distance, which is basically how big the tiles are that he's moving. Whenever you move him, we want him to move 8 pixels, for instance. But move distance is more specific than something like tile size. Tile size could be used for other things too. So we'll use this constant here. So dude moving and you know what? We don't even need move timer anymore because he's going to move 1 pixel, basically 1 pixel for the 1 pixel by 1 pixel through the tile. So move timer. Let's just call that tile size, like I said earlier. And instead of dude being like multiples of 8, instead of multiples of 1, we'll do multiples of 8. And you can see here that when we draw dude, because he's in his own drawing function, we actually use the map offset and then take his location and multiply by 8 anyways. So since we can get rid of that, he should draw like he normally would. Now we do have this draw map tile function to draw the tile where we're at, but this should make a little bit more sense that we can actually draw the new tile and old tile using this information. Let me show you what I mean. Okay, so whenever we begin the level, we load the level, we take circuit dude's location based off of the start tile. But like I said earlier, it needs to be multiplied by tile size. And in fact, anywhere we see something multiplied by 8, it's because it's being multiplied by the tile size. So these locations here for draw map tile, we can also swap them out for tile size. Even here for when we're erasing, we have 8 times 14, or we can say 14 times tile size, 8 times tile size, because the map is 14 by 8. Hello, Sherwin, John, Hadoy Kadoy. Thank you for calling me Witty Talaga. I appreciate that. Tariq, how's it going? You said you got your M5 stick and tested it. The code, it works. Having trouble getting my rover to work properly, but I'll test it with the joystick when it comes in. Cool. Hey, I don't know if you have like Twitter or something. I forgot how you originally contacted me. Maybe it was on email, but I'd love to see some pictures if you ever get them up anywhere. Okay, so like I was saying, we're swapping out some of these hard-coded numbers from earlier with tile size. Over here in the draw map tile, we erase a tile with this rectangle, and we actually use these 8s here for tile size as well. So eventually, if we wanted to have high definition graphics, we could increase tile size to be like 32 by 32 instead of 8 by 8. And then we down here have 8s again for draw bitmaps and for drawing bitmaps here. Do I have any more 8s anywhere hidden? Let's find them. Nope, I don't think so. Cool. Let me do one more search. Oh, whip. Cool. Kapogi. Salamat. Oh yeah, you did send me a message on the Artie Boy forum. That's right. Okay. So let's kind of take a look at where we're at now with dude moving, or move dude. We still have this direction, input direction, and what we're doing is we're still teleporting him because we're moving his location. Dude moving now has like a timer in it. Instead of just teleporting circuit dude, let's actually move him based off of this timer. We could also do something like having a destination tile set and his current tile location. So that would make these functions down here, draw map tile, a little easier. Right now, whenever we do this, we should actually divide these by 0. I mean by 8. And I'm breaking my rule. We should divide them by tile size, actually. But this is just his current location. I think this might not have any problems running, but it's not going to really produce anything interesting or worthwhile looking at. But I'll run it anyways to see what happens. Type mismatch 316. Oh, dude moving. Okay. We need to set dude moving instead of false. We need to set it to the timer's maximum limit, which is tile size. $318. $318. It looks like we are having a type mismatch again because I'm dividing an integer by another integer or constant, and it gets a float. So I think we might need to do this. Let's just comment out the second one for now and see what happens. A type mismatch. We might need to look at the documentations one more time. Or typecasting. Yeah, so it looks like you can use long int with the parentheses, but it doesn't say int with the parentheses. So maybe I need to do integer instead of int here. Oh, you know what? I think the reason is this needs to be div. Type mismatch again, huh? Type mismatch 318. So it looks like we can cast an integer using the word integer. But this isn't liking it. Oh, 321. Oh, perfect. It looks like it worked. That was the right combination of stuff. And then 321. Did I not save it? 321 expected a semicolon. Oh, this is y. Duh. Doi. Okay, so dude moving needs to be decreasing by 1. I misspoke earlier. And then we don't need the dude moving equals tile size because we do it up here in move dude, which instantiates or starts the movement process. Let's move it to the emulator and see what happens. Okay, so it looks like he's still moving around. I think it's if I just try to move, it kind of has a delay, which I think is the timer working, but you can see that the tiles aren't being properly drawn or properly updated. Oh my, ooh. Oh my, ooh. Okay. So here we're just drawing I think the new tile that Circuit Dude is being moved onto. And Circuit Dude is still teleporting, and that's because of this code right here, where we just move him by 8. We don't want to do that. So when we draw Circuit Dude, he is being drawn here at Dude X and Dude Y. But we also want to have some other kind of offset. So we'll have some local variables here for X offset, Y offset. Okay. So based on the direction of Circuit Dude, we want to basically modify these offsets. So his X offset is going to equal to, if he's moving up, Y offset is going to be dude moving, which is his timer. And let's do that with down as well. But because he's moving down the screen, oh wait, up the screen is this way. We have to do 0 minus, that's right. There we go. I think that will let him slide around. Let's just add these offsets in. end expected. Oh, I think we wrote a new function and forgot to add it in. What line was that? 304. Right here. Wait, case of end. Oh, semicolon, of course. Moving it over. Let's see what happens. Okay, it's not even being drawn anywhere except for here. And that's because his new location, dude X, is not being changed whatsoever at this point. So we need to actually update this when the timer equals to 0. So dude moving So if dude moving is greater than 0, then we're going to go through this process. Like we said, it's going to count down until it reaches 0. But whenever it gets to 0, we want it to do something, which is basically change his location on the map. But if we do that, then we have to some way change from dude moving 0 to something else so that it doesn't keep changing his location over and over and over again. And if you watch what I do here, I think it'll make sense to you. So instead of doing dude moving is greater than 0, let's say dude moving is let's see. If dude moving is equal to 0, then we're going to update his dude X to be his current location and dude Y to be his current location. And that current location is the location of his drawing, his bitmap being drawn right here. You know what? I think we might need to go back and redo some of these variables. Yeah, we might need to go back and do some of this. You know what? I think what we can do is this. Whenever we're drawing circuit dude, we can take all of this code right here, dude X plus X offset, and save that off to a variable. And that variable is literally where circuit dude is going to be drawn on the screen. So let's call it drawn dude X and drawn dude Y. Now let's use them. And then down here, below that, whenever we actually get dude moving to 0, then we'll just change his dude X and dude Y to what it was calculated when we were drawing him. And now we're always going to have dude moving equal to 0 after he's moved. It'll count down to 0 and then stay there. But we don't want this to happen all the time because it'll slow stuff down a little bit. Or we might rely on this in a little while when we do the onLeave function or onEnter function. So let's say dude moving equals to -1. And that should work for us. Let's go ahead and run that and see what happens. Oh, I also need to instantiate these. Not instantiate, I'm sorry, declare them. There we go. Alright, it loaded, it compiled. Let's put it into the emulator and see what happens. And nothing happened. But he was drawn in a slightly different position. So let's go ahead and go over here and figure out why that is. I wonder what I do in the Artie Boy version. Draw dude. So this is what I do right here. Position X and position Y. I use the X and Y position on the screen to draw him. And let's see where we set that. Load level. Yeah, we set it when we load the level. Teleporting. Really? That's all we use it for? What is A pose Y? Huh, unused variables. I don't know why I have these. Okay, well that doesn't really help a whole lot, but draw dude. I think what happens if we set dude moving at the very beginning to instead of 0, let's try putting it -1. I think that might prevent him from being displaced. But I don't think that'll let us move. Oh, well, it didn't. So, oh, here we go. If dude moving equals to 0, that's right. So we want to make sure that he's done moving at -1, not 0. All right. Oh, look at that. That's odd. But he's moving diagonally, so that makes me think that he is moving based off of the same variable being used twice for his coordinates. So there's somewhere where I'm doing dude x instead of dude x, dude y. Something like that. Dude x, draw an x. Oh, I see. I see. So we don't want to actually move him. We don't want to do this stuff unless dude moving is 0. I mean, is -1. Then, no, is not. Yeah, if it's not equal to -1, actually, if it's greater than -1, let's do that. That might be easier to understand later. And now let's try it out. Oh no, he's still moving diagonally. And not properly either. He's offset by a little bit every time he moves. Y offset, up and down, X offset, left and right. Move do. Let's see where we call these. I wonder what happens if I restart this game and push up. Maybe the casting has something to do with it. But I think like I was mentioning earlier, we might want to change the methodology for input direction and for drawn dude. I think I want to get rid of that and specifically manipulate dude x like this. Dude x equals to the offset. Dude y equals to dude y plus the offset. Instead of drawn dude, we just have dude. Oh, we don't need this here. And I guess let's load that up and see what happens. Okay, so he's drawn in the right spot. Let's try moving him to the right. Oh my gosh. Okay, he just went off the screen in a diagonal direction. I think maybe this needs to be moved up here, but I don't think it really does anything. It just adds an extra frame of movement. Okay, so if dude moving is 0, which is effectively his last movement, He's either moving or it is his last movement. And I don't, this is called Draw Dude, but this might be better called like Move Him. Even though we already have a Move Dude, that's like the start of the movement. So I might call like Movement or something like that. Instead of Draw Dude, and then we'll, I guess, have another function. We might need to break this out, is what I'm saying. Effectively, what we want to do is have these tiles set up 8 pixels by 8 pixels. Have a location here. Move it this way. Whenever you're moving right, so you move this line. You're moving this line until it gets to here and then it stops. And then it calculates on what it needs to do here. So we have that timer to move. Dude, timer. Dude, move, dude, move, moving. That's what I called it. Okay. Okay, so whenever I push the right button, what happens? If dude moving equals -1, which it is, then his dude moving equals to tile size. And we have this offset here. I think that's because the timer is set to 8. Let's say I move up. How many pixels up is it supposed to move? Well, initially it's supposed to be 1. So I think it needs to be, instead of 0, it needs to be tile size minus dude moving. This will start it out at 8 minus 8, and then 8 minus 1, 8 minus 2. Yeah, that's what I think it's supposed to be. And for these two, I think it needs to be 0 minus them. It needs to be inverted. So let's just run that real quick and see what happens. Okay. It's still drawing diagonally for some reason. And no matter what direction I do, Is it because for some reason input direction is not set to 0? I mean offset. It's not set to 0. I don't think this is it. How does that lock me out now from being able to move whatsoever? That doesn't make sense. Yeah, why does that work like that? When does input direction change? Offset should always be calculated. Always be calculating while dude moving is greater than 1. So input direction equals to stay, at the end of every frame. So instead of that, input direction. Okay, that's right. So we do want input direction to basically be cleared out every loop, but we want to retain the direction that circuit dude is told to move in, so that if you are told to move left, he's moving left, and we remember that direction, despite the user inputting something different. Like, if you're holding up and then you suddenly push right, you shouldn't go right in the middle of a tile. So we need to do direction to retain that. And so input direction do moving, do direction equals to stay. Input direction. So let's use do direction here instead, because do direction won't change until circuit dude finishes moving. Now, when do I need to use input direction? Input direction needs to be used whenever you're using move. Dude. Wait a minute, so I don't know what I just did. Yeah, what did I just do? I guess I didn't do anything. I just duplicated this variable. Okay, I think the biggest, most important thing was setting dude direction while dude moving equals to 0. Oh. So we have here it moving until I change the direction. Oh, actually, it does look like it moves on a grid. Look at that. So weird. So he moves on a grid, but he's not moving on a pixel by pixel basis. He's moving a lot more than that. So we got to figure out why he's not moving 1 pixel at a time. And I think I know why. We don't want to do this offset. We want to, this offset is huge. We want to increase or decrease dude X or dude Y by 1 and only 1. So what if we do this? Y offset is 1. Down equals -1. Tile size is 1. X offset is 1. No. Yeah, X offset is -1. X offset is 1. That's what I meant to say. Too many words. Okay. Let's see what happens. Oh, sweet. So he moves, but we don't do the erasing afterwards. And also the up and down directions are inverted, which I thought they might be. Okay. Okay, so let's go ahead and draw tile maps here. We were thinking about doing some calculations to figure out where to draw, but we have enough RAM here instead of on the Arduboy. We could do this. We can have, let's see, dude X. Where is that defined? Instead of dude X and dude Y, we can have dude tile, which is basically what dude X was. Dude X tile and dude tile Y. And then we can also have a destination tile as well. So the current tile, or the one he's from, and the one he's going to. So we can say to tile and from tile. And it looks like we're using a lot of this kind of, we're making this file really long, so let's cut down a little bit on this and compress some of these lines of code. Anything that has to do with coordinates, I'm going to just make them a pair real quick. There we go. All right, so we have from tile and we have to tile. And the drawing code should be pretty easy. We'll do this. To tile X, to tile Y, and then also from tile. There we go. Now we just have to calculate these. So whenever you instantiate your movement, that's when we want to calculate both of these. So move dude. So we use that up here, but let's copy and paste this case real quick. And we'll set from tile X to be his current tile, which is dude X divided by 8, or tile size, I should say. And let's go ahead and cast that to an integer to round it. It should always be rounded. It should always be a whole number, but the compiler is going to get upset with us. And let's do this. You can use these same variable names and just reuse these cases and say that tile x is going to be an integer of dude x. We probably need parentheses, dude x plus x offset divided by tile size. We'll do that with the y as well. Cool. So now we have these calculated out. We should be able to run this and have the drawing work, where he's not smudged. Instead, the background is being cleared out from underneath him. But, oh yeah, we wanted to compress some of this stuff. So I'm going to go ahead and do that with a few of these functions just to double check, make sure things look a little nicer. Those look fine. That's fine. That one. Let's do this. Yep, those all seem fine. Okay, let's compile and run it. Oh, invalid typecast argument, 241. Dude x, file size. Hmm. 241, invalid typecast argument. It's interesting because that's what I did earlier too. Oh wait, do I not do that anywhere? How did I cast earlier? What did I do? Are these the only places I cast? Oh, that's right. Okay. That's right. It needs a different operator. The div operator instead of the division symbol. I'm gonna have to keep remembering that because that's a weird Pascal thing. Alright, let's moment of truth right here. Yeah, when draw cars, yeah, I should probably do that to help debug. Uh-oh. Okay, moving around looks like it doesn't work. It caused a crash. Okay. Let's figure that out. You know what, Galactic Discat? I'm gonna go ahead and kind of note that up here. It's a good tip. Okay. 2 tile. So I'm going to oh, wait a minute. I think it's because I have these offsets. Basically, I will take an offset and manipulate it. No, I'll take a value, a dude x value, and manipulate it with the offset. So it might be -1, decreasing it. If dude x is 0, then this will become -1, and -1 over 8. Well, oh, actually, I see. I think these need to be tile size. No, I'm wrong again. Okay, I think I know what I did wrong. I think I'm reading outside the memory. I think I might be reading outside the memory, because if you move over and somehow made 2 tile x negative, you can't look for a tile that's in an array at a negative index. But I also did some incorrect math, so I'm going to check the incorrect math stuff real quick. Yeah, it looks like it's still messed up. Alright, 2 tile x and 2 tile y. I'll oh, wait a minute. Yeah, I'll choose not to use these for now, and only let the from work. The from tile x and y. Load those and see what happens. Okay, so he is moving. Like I said, there's some smearing. It's hard for me to tell what's going on, but my instincts are that whenever you move from a tile, just kind of like that, the tile should disappear as you start your movement from behind you, the one that you're currently stepping on. Huh, and this one down here, it's because it's doing this diagonal thing again. So I think I need to go back to that, figure out what I'm doing here. And now it's the from tile. That's messing up, actually. It's in this diagonal pattern, it seems. What if I move to the right and then up? Oh shoot, that was way too fast. But yeah, you can see the diagonal more there. Oh, it's sticking out to me. What the heck? Right here. Dude, x divided by tile size, dude, x divided by tile size. Copy paste mistake. Alright. There we go. That's what I imagined. Okay, so his movement. The tile he's moving onto is still being smeared, but the one he's moving away from isn't. So for some reason, this code is causing an error because we're trying to draw stuff that's not in the array. So my thought process is for this is we have to come up with, let's see. You know what? We could do this too. I don't think this might fix our problem. I don't think it will, but maybe it has something to do with the division. rerun this. Okay. No crashes yet. That's interesting. Oh, it's because I don't do anything with those values. All right, reset. Okay. Draw map tile 2 tile X 2 tile Y. So if you're on tile 0 and you move up, it should crash. But if you move down, it shouldn't crash. And if you move down, what's happening is from tile Y is your current location. Oh, wait a minute. This is... Yeah, okay. From tile, if you're moving down, then you should be adding 1 to your from tile, but your X offset should be 0. Do I ever do X offset equals to 0? Yeah, I think this actually is an issue. I think there's just some random memory. These don't have values associated with them, so it might be garbage data that coincidentally sometimes is okay. That's what it was. I can't believe it. Okay, so this is super slow. Super slow. I think we can increase the frame rate of the game. And div 16, is that what it is? Div 12? Let's see if we can do div 20. Try to set it to like 20 frames a second. Can you believe that? That's so fast. Oh my gosh. There we go. So we effectively have here sliding between tiles. It is a little bit choppy, but it works. And let's make sure it works on animating tiles. Yes, it does. Okay. So our 4 goals for the day were sliding between tiles, entering tiles, and causing something to happen, leaving tiles, and then swapping tiles. So we went ahead and we did the first one. So I'll just strike through. And I will, let's see, where's it at? I'll go ahead and update this little progress bar to be 27%. Ooh, the one underneath me. And let's go ahead and do the on enter event, because I think this one's going to be more immediately apparent as to what happens. But from tile X, yeah, that's going to be super helpful. So when we enter into a tile, what happens? The counter reaches 0 and something fires. So in the case of this Artie Boy version, I'll step on this chip and you can see my background quickly changes as I stop moving. That's because the chip is being placed underneath me. What's happening is it's finding the current location in the map that I land on and then swapping out the tile. and it just swaps the value in the memory. And whenever I land on one of these conveyor belts, what it's doing is it's like checking, oh, I'm on a conveyor belt, then I need to do this action, and the action is move to the right. So it automatically sets me to move to the right. Later levels will have like trapdoors or teleporters, stuff like that, but they'll all use the initial on step or on enter functions that we're going to write here. So let's do move dude. So moving and fires off the movement. So when we have on leave, that's where we will put it in the move dude. But the dude moving timer, we use that to check to see if we ever equal to 0. And if we do, we set it to -1 and we set our direction to stay. Now this fires off only whenever we finish our movement. And so this is a great place to do our on enter. Our on enter function. And our on enter function is going to take the I guess it doesn't have to pass it, but we'll go ahead and pass the location of circuit dude, which is 2 tile X and 2 tile Y. And call it this procedure on enter. It'll take tile X, tile Y. Wait, is that how you do it? No, like this. Integer, begin, end. So chat is a little quiet today, but I want to let you know that I'm still reading everything you post, and I appreciate what you guys are saying. But if you could, just real quick, I want to plug my channels again. I like to do this maybe once every hour, hour and a half. But underneath me, right here, is my website where you can download Circuit Dude for the Ardu Boy and some other games I made. But also below that is my Twitter handle where I post whenever I talk about streaming. This Sunday I might not stream because I'm moving that morning and I have church stuff I might do. So I may not be available during the evening to stream. So if I don't ever stream, I'm gonna post about it there. So if you follow me, you'll be the first to know. But also YouTube and Mixer and Twitch, I'm going to be on streaming simultaneously. So whatever platform is your favorite, check me out there, follow me there, subscribe, do whatever you want. And that lets me know that you're interested in the game that I'm writing. So it'll help me to keep going. And if I ever have to pick one platform to focus on, whichever one that you're most engaged with is probably going to help me determine that. So. All right, let's get on to this on enter function. So the on enter function is going to be like a big switch statement. What it's going to do is it'll be case. Let's see, case. What is it called? Current map. Current map, and it'll be tile X, tile Y. So basically, depending on the current tile that we're passing in, and I guess we could have done this too, but okay, anyways. And we can say if it is a exit, I think I call it exit S. Then we can say load level current level +1. I think that's the code we use later on. Yeah, so this is the code we use when we scroll through the levels by clicking on the screen. So I could say, if you on enter, if the level is exits, or if the tile is exits, then do this code. And we'll go back and update that, but if it's something like chip O, which is basically a socket, it means the chip is out of that tile. Then we want to put the tile in, like the socket, I mean the chip into that socket. So we can say current map tile X tile Y is equal to chip I. So stepping on this tile should go ahead and put the sockets in, the chips into the sockets. So I'm going to run this one more time. I think from here on, we're going to be making a lot of really quick progress. I kind of have the language down pretty well. Oh, shoot. I did that wrong. I just stepped onto a tile that was a socket. Huh. Oh, I think it's because anytime I talk about the current map, I do it in reverse. That's right. Okay. So these need to be swapped around actually. And that is the mistake I have to live with for originally doing it wrong in Circuit Dude. And there is an actual technical reason why I do y before x. I might show you guys a little bit later. It seems kind of stupid anytime you write coordinate pairs in math and stuff, you do x and then y. But there is a reason why I flip them around in the Arduboy version. I just don't like that I have to remember that every time. Okay, so let's see what happens. Oh, look at that. Oh, the tiles change. Alright, so I went through, plugged all the chips in, and I should be able to go to the next level. Boom. Beautiful. Huh. Oh my gosh, if I hold it down, I move so fast. Okay. I noticed that if I go out of bounds sometimes, if it doesn't crash, it'll draw a nothing tile. Okay, so another thing that we want to do, we could go on and program out all the tiles. I'm going to leave a placeholder here though. Let me see. It might be a little hard to see this. I wish I can zoom in more. Maybe I can. Nope. Okay. So on the right is the Arduboy version of the game, and I have here basically a list of tiles that you can step on. And I'll run through them real quick. I'll go ahead and just program them out and stub them out, I should say. So if it's a block that you land on, it's a solid wall, nothing can happen. You shouldn't be able to even land on there. A blank, start, we already went over exit, chip O, already did that, LED, can't step on. And then the conveyor belts. If you stand on a conveyor belt, there should be something that happens, but for now, let's just write a note to ourselves. Oh, I forget we can't write notes like that in, okay. Okay, so So we'll do this whenever we have a tile that we don't know what to do with. So conveyor belt up, down, left, right, and whenever we have the button, the conveyor belt button, what we're going to do is swap all. This is a function we haven't done yet. I think I can do this. Let's see. I have a special. Actually, you know what we can do? We can do this. We can just look at this function. Yeah. So whenever we stand on the con B, the conveyor belt button. Let me blow myself up real quick and show you what that button even is. So you see these conveyor belts. You have to move on them in a given direction. Spoiler alert too if you were trying to play this game and beat it on your own. I think the next level has the conveyor belts. Conveyor belt buttons. I think I just ruined myself. Ruined it. I was getting ahead of myself. Okay, so on this level we have this button, this new tile mechanic, and it's the con B button that you see in the source code. And so what happens is when we step on it, it reverses the direction of all the conveyor belts. What's actually happening underneath the hood is it's swapping all of the con R with con L, and all of the con L with con R, and all the con U with con D, and con D with con U. So to be able to do something like that, over here we're going to see con B. You can see how I have the swap all. Oh, I also have a change function. You know what? We need to do change as well, which is swap all swaps all the tiles in the entire map that are one with the other, and change just changes all of them from one to the other. So this will be con D and con U, and we'll go through and write both of these functions actually because they're both very similar, and con R and con L. And as you can see in the Artiboy version on the right, we also do sounds whenever you step on certain tiles too. So we can include that later on here. Let's look back again to see what else we're missing. So we have the conveyor belts, we have the conveyor belt button. Instead of stub, let's just write what it'll do. Move circuit dude. Okay. And trap C and trap O. So trap is another thing that we haven't seen yet. Trap O, if you step into a trap O, an open trap door, you'll die and you'll have to restart the level. So, but you'll slowly like fall through. So for now, let's just write that you load the current level again to restart, to simulate your death. And after trap O, we have cap B, which is a capacitor button, and capacitor buttons swap all of the cap O and cap I's, which don't do anything if you step on them. So this is a really easy one to program out, and that is con B. Swap all con I, con O. And we can go through these levels and I can show you real quick what these look like. And teleports you, but I don't necessarily have that find out how we're going to do that together. What's the next one? Rot B. Rot B rotates all the rotation pieces. And I think this is the last one. I think this is the last one. So we'll look again how we do that on the circuit dude for the Ardu Boy version. Oh darn it. So we swap all rot V, rot H, and then we do these. I'm just going to copy paste it because I use the same variable names. Okay, so we have change and we have swap. There's another time that we're going to use change, but let's go ahead and program these out, okay? Change is pretty easy. What change does is it, like I said earlier, it's going to go through all the tiles in the map and change all of the tiles from one tile type to a different tile type. So, let's see. Raw map. Tariq, I appreciate that, man. Thank you so much for letting me know that. Yeah, I hope the move goes well too. I think the best part of moving though is going to be getting out of the current apartment that I'm in. It's super noisy, all the construction going on. Luckily, like I said, I have a friend who's letting me stay with her in her extra bedroom for the week. Okay, so change is going to take a tile from tile to tile, and these are going to be integers because they're tile types. And as I go through this tile, this map, I'm going to say if that tile equals to from tile, then that tile is going to become to tile. Okay, so that should be good. Now for swap all, we're going to use the same parameters from tile, or no, let's call it first tile, second tile, and these are integers. And this is a great time that we can reuse our code. We can actually change one from the other. It would be really difficult to say like change first tile to second tile and then change second tile to first tile. It would be kind of hard to do something like that because you're taking all of, tile A and replacing them with tile B. And then now you have a whole bunch of tile Bs, and you're taking all of those and turning them into tile A. So you no longer have any tile Bs. What we want to accomplish with the swap all is to preserve the difference, preserve the fact that we have two different tiles. We just swap the values, so some, swap places, but if you have 3 of one and 7 of the other, you should end up with 3 of one and 7 of the other at the end. And so I've devised a way to basically use another tile type that I have here called hold to swap them around. And if you look here, it's just an X. It doesn't do anything, and you never see it in the game. The only time you see it is in the what's it called? The level editor. So we're going to take all of the first tile and change it to hold, and then we will move all of the second tile to first tile, and all of, hold, and change it to second tile. Yeah, that should be it. And let's run this. Okay, 348. Unknown identifier. Oh, okay. Y, X. 341, unknown identifier. Did I not save it? 341 at 9. Oh, here we go. 341. There we go. Forgot to declare those variables. 374. Unknown identifier on 374. Con B, con I. Oh, okay. So I see what I did wrong. So the conveyor belt button should actually, wait, I have 2 of them right here and here. It's supposed to be cap B. And this is supposed to be a cap I and cap O. That should be it. Yeah, that's the ticket. Alright, so let's do this. Let's move. That still works. And let's go ahead and see that level with the button. So I should be able to step on it, and it should reverse the direction of this tile, of this conveyor belt. And it does. Excellent. There's another button down here, and we should also see the vertical conveyor belts move, which we do. Perfect. And if we walk into this hole, it should die. Perfect. And here we go. This one has a cap button, a capacitor button, or cap B, which, that one doesn't work. Cap B, on enter cap B, swap all cap I, cap O's. Let's look at the Arduboy version. In the Arduboy version, I actually don't take any parameters with my function name, so maybe I should do this too. Get rid of them. Yeah. I use 2 tile X and 2 tile Y. Alrighty. If the tile that I land on is a cap B, then I swap all cap I and cap O. That's what I have here. See what happens whenever I step on it with cap O's. So these are cap O's and these are cap I's, and they should basically swap. And they only swap whenever you step on them. Cap. Huh. That's interesting. So cap I turns into cap O. Whoa. Oh, I think I know what's wrong. It's because I don't redraw the map whenever I swap these tiles. So let's go ahead and whenever we do a swap on enter, let's also do this. Yeah. Let's set the map to redraw. So here, 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 and here, we want well, I guess not on chip O, because that will be automatically redrawn. Is it? Is it automatically redrawn? Or is it only redrawn when I leave? Yeah, I think it's only redrawn when I leave. So I want to somehow set everything to be redrawn after I make these changes or these swaps or whatever. So redraw equals true. And I'll make a variable called redraw. Make it a boolean. Draw map dynamic. So during gameplay I draw map dynamic here, but let's do if redraw, then redraw equals to false, and we also will redraw the map. So draw map static, which we went over last time. Cool, man, I'm so excited about this. 360, we have an error. Let's look at that. $414. Okay, we don't need the parentheses. All right, let's reload it. All right, so the tile should swap and the chip should be inserted as I land on it. Okay. It's kind of weird seeing the socket through Circuit Dude, but huh. Okay. We were looking at these buttons. So the reason why the conveyor belts were working and this one wasn't when they would swap is because the conveyor belts are dynamic. Perfect. Look at that. That's so cool. And I guess the other button that you can step on to change things is this rotation button. And let me find a good level to show off what's going on there. Okay, so you have these like corner pieces here. They look like L's. And you also have this little tunnel. Whenever you step on this button right here, the arrows, you should see these rotate. I want to pull up the magnifier real quick. And yeah, so these tunnels right here, and these should all rotate clockwise 90 degrees whenever I move on. Oh my gosh. I just ruined it. Let me find another level. I might have to restart. Okay, this one's fine. So you see the tunnel right here, the L-shaped things right here. So if I step on this little arrow button, it should all rotate. And I do. Excellent. So the concept for these is that you can't enter them from the right or the bottom. And if you want to enter onto the space, you have to rotate it. But as soon as you step off of it, it also rotates. So primarily the on-leave mechanic is going to be used for these tiles. But we also have another tile that we want to use the on-leave function for, and I'll show you that real quick before we start programming it in. It is, let's see. So this is actually an open trapdoor. And this is the first level where you see the trapdoors. So you're kind of inclined to go into it and see what happens, and it'll kill you. But this is what they look like when they're closed. So it turns from this to what you just saw whenever you leave, effectively making it a one-way step, a one-way direction that you can go. They're not necessary to open up in order to beat the level, so that's what makes them different from the capacitors. I mean, the computer chips. And in the full version for Steam, there's actually blocks that you can push, and they can fall into those holes. So they have more uses mechanically than just blocking your direction. Now, another thing that happens too is that whenever you get all the chips, the LEDs in the levels, these things right here, also change colors. They go from LED O's to LED I, which means LED off to LED on, illuminated. So we'll also, whenever you pick up a chip, when you step on it, we also should do something where we check to see if the level's complete. And if it is, then we need to activate the exit and then swap these out. But let's work on the trapdoors for now, which is the on leave. So I'll go ahead and strike off the on enter. And also we did change and swap all already too. So this list is being knocked out so fast. Okay. So, I'll go ahead and put this over here. So, like we said earlier, the on-leave mechanic, or the on-leave procedure, can be implemented when you move dude. Now, we do want to check eventually if you're allowed to move. Some tiles you're not allowed to move onto. We kind of are walking through walls at this point, and we also don't want him to be able to walk out of the map. But, you know, just for purposes of now, we should just implement the on-leave mechanic here. So, on-leave can be here after we figured out the 2 tile X and from tile Y, and we'll on-leave. We'll just take note of the from tile X and from tile Y, and it'll be very similar to on enter actually. So we'll put it right below the on enter procedure. So on leave, and based on the current map, the X and Y of that, we'll go through these cases and do some stuff. And so what did we say? We said actually this one. What did we say we needed to do? We needed to do trapdoors. So if the trap is closed, then we take the current tile and set it to trap O. But we're not doing 2 tiles, right? We're doing from tile. Let me swap that out. So this should open the trapdoors whenever you walk across them. And let's look in here to see on leave. Let's see what else we do. We do the trapdoor. Oh, and we do these rotational pieces like I mentioned just earlier. So we'll copy that code just so we're able to look at it. But it will look like this. So if it's a rot H, and we can kind of actually, you know what we can do? We can use some cool features from VS Code. So current map from tile Y from tile X becomes that. Okay. Boom, baby. All right. So we when we leave those tiles, there's some changing around that happens. I'll go through and I'll show you that again. But just like on enter, we need to set the redraw to true whenever we do something. But the fact that I think you're always redrawing the tile whenever you leave it, so I don't think we need to redraw the entire map. BitHacks, how's it going, man? Thanks for showing up and checking out my stream. I don't know if you've been here before, but I'm porting an Arduboy game over to the Palm Pilot. Uh-oh. What did I do? Ah, well, perfect timing, man. I'll just load that back up again. Oh, you were here before? Okay. Sorry I don't recognize your name. Okay, so let's find some of those tiles we were talking about. Alright, so this one has the trapdoors. So you step on it, and as you step off, it should open. Oh. It didn't. Do we call on leave? From tile X, from tile Y is being set here. Oh, so this is if circuit dude is moving is equal to -1 whenever you set him to move. Yeah, so that is right as well. Did we miss something here? Let's try to compile it one more time. Maybe oh, okay, there's a compilation error. I didn't even see that. 260. Oh, I think I know what's going on too. So move dude. So move dude is calling on leave, but on leave isn't defined yet. So I need to move it up. I need to move this up, and I probably should move the other one up too. Right above move dude. And then 252 is another error. Unknown identifier 252. Oh, swap all. Okay. That one needs to be moved up as well. So on leave, on enter. Now it should be able to be. Ooh, okay. 304. Oh, I misspelled this a little bit. Forgot the P. Alright, let's move it over. Okay, let's go over this trapdoor and see what happens. And it opens, perfect. So the other test is the rotational pieces. Like, oh, actually, that was a good level to test, darn it. All right, so this is kind of how they would be used in the level. You step off of them and they rotate. So it kind of changes the level, makes it a little more dynamic. And you're not supposed to be able to move in two of the directions to step off of it. It's like a rotating wall. And that works too. Cool. So I guess we have the on leave also done. And so I'm going to go ahead and update the progress of this. Let's see. And I'll put us at 34%. I think we're probably about we're probably about 37%. That's super scientific, right? And that's fine. All right, the next thing that we want to do is, like I said earlier, is turn on all the LEDs whenever we beat the level and check the level to make sure it's complete or not. So we'll do that on enter for the chip O, which is the socket, the chip that's out of the socket. And And then we want to, if it is complete, make up all the LEDs, change all the LEDs from off to on. So let's do that. So on, enter. We have here we're putting in this chip O, but we also want to check for completion, or check complete. And that procedure can just be written up here. Check complete. And let's also have this a global variable that we want to access, and it'll be called level complete. Yeah, check complete and level complete. Level complete would be false by default. And when we load a level, we want to make sure that we set the level to be incomplete. So and so kind of like we were doing earlier, we're going to iterate through the entire level and set level complete to true if we iterate through the entire level. But if we find a socket that's empty, we'll leave level complete as it is. So if the current tile is equal to chip O, then exit, and let's just for the sake of it, level complete equals to false. Okay. I want to see how I did it in the Artie Boy version. Check completion is what I called it. So I said level's true. The level completion is true unless we find one. So that's kind of important because the game has a level editor, and we want to make sure that the level checking is the same exact way for both versions, so that essentially you can make the same level in both games. And what in theory you could do is create a level that has no chips at all, and the level will automatically be completed from the very beginning, and you have to somehow get from the beginning to the end. So just by doing check complete and saying level complete is true, just by firing off this check until we get to a chip socket, then we'll be able to ensure that. So we'll also, with that being said, when we do load level, we'll go ahead and check complete right here. And I want to see if I do that, check completion. Oh, okay, never mind then. It looks like the only time I check for completion is whenever you step on a chip. So I'll get rid of that. Check complete. So I step on the chip, I check for completion, and okay, and then I use the level complete variable whenever you step on an exit, which is right here. So if level complete, then load the next level, essentially. Cool. Let's go ahead and just run that. I know I make a lot of syntactical errors, and yep, just like that. 238. I'm just not super used to Pascal yet. There's a lot of weird things about it that I'm just not used to. So now I shouldn't be able to go to the next level just by standing on this spot. I need to actually step on these chips. And now I should be able to. Perfect. Let's go ahead and whenever the level's complete, let's light up the LEDs. And level complete equals true. So if level complete is false, we'll actually exit this procedure early. And if we don't, this is a great place to put in change LED. Oh, I guess change LED to LED on. I thought these were called LED I and O, but LED to LED on. That'll turn the lights on. And I think when we draw the map, dynamic, draw map dynamic, we actually are going through these right here. We're going through these frames, these animation frames, and redrawing this tile itself for the conveyor belts. But we also want to, whenever we reach the exit portal, let's just check to see if the exit is if the level's complete. If level complete, then tile becomes, and I think it is, if we look here at the no, where is it at? I think it's in the Arduboy source code. Yeah. Sprites. Oh, here we go. Spritesheet.png. I'll zoom into this too so you can see it. Yeah, so this is the exit portal, but whenever you complete the level, I want to scroll through that, and then back here. So it'll look like a zooming effect. So I showed these three tiles back to back to back, those sprites. So what I should do is say that the bitmap that's going to actually be drawn is going to be blocks at exits plus frame, because remember we have that frame variable from last time for animations. I think right now it only goes up to 4, but we should be able to mod 3 to do some quick math to get that to work. Okay, 263. Okay. Gotta move some functions around again. Okay. There's something wrong with this. We're reading outside of our we are reading outside of our array for some reason. If level complete, then tile becomes blocks exits plus frame mod 3. Maybe it needs to be this. Maybe there's some order of operations stuff going on with Pascal, but we really shouldn't be running this unless we complete the level. Yeah, we shouldn't be able to run this unless we complete the level. So level complete's false. I'm gonna try this, and if it doesn't work, then we'll try something a little bit different. Yeah. Let's do this instead. Exits plus frame. Okay. What does blocks look like? Tile is a bitmap pointer. Blocks is a bitmap pointer. Oh, that's right. It's because I don't have these necessarily defined. Okay. So I have to go through and define these images. +1, +2. And res exits. It looks like we have to actually do these exit animations individually, unfortunately. Man, totally forgot about that. Two, 3. But it really shouldn't take too long. I did the, what's it called? The conveyor belts earlier by myself. It was pretty easy. So maybe this won't take too long. Oh, that's not what I meant to do. I meant to do this. If you're still here, Triforce, this is some high tier level MS Paint strat right here. I'll save as BMP. Exit. Oh, no, not yet. Circuit dude, files, exit 2, and then instead of 24 bitmap BMP, let's do a monochrome. Okay, let's do the next one. Exit 2. Wait, what? Exit 1. This should be exit 1.bmp. Okay. Okay, so the exit stuff is there, exit stuff is here, and exit stuff is here. So I think I should be able to go back to frame mod 3 and to basically recompile with the new resources I just added, those BMPs. I need to regenerate my .ro file, which is what the Pascal will grab whenever it's compiling. Where's that at? Oh, here we go. Generate res exits 1. Oh, that's right. There's one more thing up here. Two, three, 1, 2. Okay, that worked, and now duplicate identifier on line 76. Let's see what that looks like. Circuit dude res. Oh, this one. 2. Okay. All right. I was still having this issue. Which means these bitmap pointers aren't pointing at anything. Let me go through and regenerate this stuff one more time just in case. Darn. Exits. Frame mod 3. Let's just do exits plus 1 and see what happens there. Oh, okay. Blocks exits. So if this doesn't work, I'm not sure why. Yeah, this is like a caching issue, I think. It might be where I throw the... One, 1, 1, 3, 1, 1, 1, 3, 1, 2, 1, 3, 1, 3, 1, 3. Huh. Oh, I see. Okay, I don't actually... There we go. That might be the issue. That might be the issue. Go! Okay. We can figure this out. This might be okay. We might be able to figure this out. Let's look at exits. All the place where exits appears. 1 1 3 1 2 1 3 1 3 1 3 1 0 1 2 0 1 2. Okay, that's good. I think that's good. Huh. I have constants for them. Totally forgot doing that. Okay. Exits. So what do I call this? Exits 2? Exits 3? I think that's the proper way to do it. But exit 2, exit 3. I'll actually call this 1 and 2. Ugh. All right, let's check one more time. See if it's a resource thing or if it is not. We could check that with here. By the way, guys, I have been eating so healthy this week. Tomorrow is Friday, and Fridays are my cheat days, and I get to eat whatever I want. It's amazing. It's beautiful. And I usually always go to eat at Raising Cane's, which is like a place that serves chicken tenders for lunch. And then for dinner, I always go to Raising Cane's again for a second meal. And it never gets old. Oh my gosh. Okay. Use sure. What is sure? What do you mean by that? Use sure? What does that mean? So it is a resource issue because it's not being read outside with the blocks array. It's something to do with the blocks array with the resource being pushed into it. Nine, 10, 11. Are these exits in here? Exit 1 and 2. I wonder if I call it exits with an S. Am I sure? Am I sure of what? Sure one. What are you asking about? Am I sure that I've been eating healthy? Is that what you're asking? Exits. Exits. Res exits 1 and 2. Res exits. When I was in Korea, I had a bunch of chicken, and I had a lot of Japanese style chicken, but I don't think I remember the name of it, unfortunately. But it was all really good. This is a weird resource issue. I'll do. Oh, okay. So I've commented out this blocks thing, and where I set the resources, I'll comment that out too. See what happens. Oh yeah, I have a card, a VIP card, that I use whenever I go to Racing Canes, and it keeps track of how many times you go. And I'm almost at 300 visits, but then my wallet was stolen, like I was saying the other day, out of my car, and I had my card in there, so I completely lost that bragging right. So I did comment out these blocks, these definitions for these bitmap pointers, and I'm still getting an error for some reason. This should be like rolling back. But it's not working for some reason. I think I can also comment these out. So if I comment these out, they shouldn't be included whatsoever. No, this doesn't make sense because for some reason the level's kind of drawn. Look at that, the level's drawn, but the exit isn't for some reason. Like it's a dynamic tile. Like it's being run in a dynamic tile call. Which means that there's a caching issue, I think. Let me delete the PRC, which is the compiled POM file. I'll do a hard reset. Let's regenerate everything too. And I think actually I should do this. Delete it from the from memory and then reinstall it. And it's still not working. So what gives? So case current map YX of exits. Begin. Is it this? Is this the issue? What? How does that work? If level complete, I guess it's because Kyle is okay. I know exactly what the issue is. Spent way too much here because what I'm doing is I'm saying if level complete is you know, if level complete, then make tile this, but it's always going to draw tile no matter what in this dynamic array. I mean, a dynamic function with right here, this pointer. So if the pointer isn't instantiated to anything, it's just garbage data, then it's going to be wrong. So we need to do something like this. Tile becomes blocks exits. Okay. And now let's uncomment out these. Oh. And put these back in. Regenerate everything. Recompile. I don't know why that took me so long to realize. Other than that, I feel like the stream has gone really, really good. Alright, so let's beat this level real quick and see what happens to the exit portal down here. It should kind of like zoom, have a weird zooming effect. There we go. And so frame right now is, there's currently, let's see, where's it at? 20? I think 20 might be a little too fast. I like 12. I don't know if this is actually slowing things down or not, but when we had 12 frames a second, let's see, I'm gonna go ahead and change frame to 12, so it'll count to 12 for us. And conveyor belts use this, but they only have 4 frames, so we have to mod 4. And down here as well. Wait, why do I do that? Wait a minute, why do I do that? Oh, yeah, okay. Frame. And so 12 is divisible by both 3 and 4, which there's 3 frame animations and 4 frame animations for the conveyor belts. So I think last time we tried to adjust the frame rate, it messed up. Or not the frame rate, but the frame counter. So we should be okay, I think. Ooh, it moves. It definitely moves slower. Oh, frick! What the heck? Okay, that does not look any smoother at all. But for some reason, if I hold down right, oh, it moves so fast. It like accelerates. I wonder if it's actually drawing. I wonder if it's the emulator or if it's actually drawing, because I wonder if maybe the game is like artificially slow whenever there's no events going on. What if I do this? Instead of 12 frames, or 12 frames per second, what if I do 60 frames a second? whoa. It's hard for me to tell if this is actually right or not. Oh, and by the way, these are the LEDs that we used earlier. Yeah, I think 60 is way too much. But your movement definitely does move. I wonder if there's some limit on how many times the screen itself is drawn. I might have to do some research to just kind of meet that sweet spot, so I have the graphics kind of moving as fast as I can. It probably stutters if it's like faster than the right frame rate. If I move it down to 24, that does look faster and still kind of smooth. I wonder if 30 is the... Oh my gosh. Okay, that did not look good. Huh. I wonder if 30 is the right amount. Dan... my friend was telling me that he's never seen a game with like more than like 10 frames per second on the Palm Pilot. I mean, whenever I played with the Palm Pilot as a kid, I was able to get like Pokemon Blue running at like 5 frames per second on an emulator on the M500. So I feel like this game shouldn't be too intensive and should be able to run a little bit better. But I think it's going to be limited by the screen hardware and how fast they can update. And I'm also super curious about the speed that I'm able to move. So let's look at this event real quick. It says handle event. No, handle event. Here we go. So this is where we actually handle input. I'm just calling move dude, as I did at the very beginning of the stream. So this should handle moving and blocking my input. Oh, okay, look at this. This is saying if moving if the timer, my movement timer is above -1, then I will actually, oh wait, no, I'm gonna do move dude, right? But if it's -1, then this. Yeah, I think the screen being drawn is like asynchronous. So I think there's some kind of, I think it's able to compute the frame that it needs to draw, as well as when the animation's over, quicker. And so you move faster for some reason. I mean, I can leave that for later on. We can figure that out. But, I mean, geez, we got through so much stuff. I mean, 1, 2, 3, 4, 5, 6 big things. I would say to complete this game, we only have like collision detection. And collision detection is basically like can enter, can leave, some tiles you can enter, and some tiles you can't, and some you can leave, and some you can't, given a direction. Same with can't enter. Anything that has to do with menus, we need to do. Saving and storing progress. And level editor. Which the level editor will be cool because we'll use touchscreen to actually implement where things are drawn. What are the other tiles that we didn't do? Depth? What is it called? Depth? So we didn't do conveyor belt movement. I think we might do that next stream. Let's see. Conveyor belt movement. And teleportation. Okay, yeah, we could do both of those next stream. And same with can enter and can leave. Those will be fun. And I think that's all the I guess falling to your death. And we can do all this next stream for sure. I think the following, what else do we need to do that's gameplay specific? UI, I guess it's part of menus. Temperature, because you can blow yourself up in the original game to restart the level. And in-game buttons, of course, like UI and menus. And then yeah, I think that's pretty close to being done. I mean, temperature probably can be in-game stuff or in like menus and stuff. I think this will be so much faster than this part because this part relies on like bitmaps being converted properly. But I think I can do that off stream. Okay, Galactic Cat, you said that the game programming book that you have says that there are 60 ticks per second on the emulator and generally 100 on the system. Not sure about FPS, but it's talking about 10 get ticks. Yeah, I think that's... Let's see, where do we do it? Yeah, this is like... That's what I'm trying to match the frames per second with how many ticks per second it'll calculate. I think it'll calculate everything great. It's just drawing is so slow and redrawing. So I mean, what if we do like M500 FPS? Oh, that might not. See, this is one of the hard things too. We are looking up stuff for old devices that might not be able to, like this data might be lost forever. But look at this. How many frames per second can the human brain process? That has nothing to do with Palm Pilot. So I might have to look into this and just kind of make sure that it's a little smooth. Whoa, during testing we were able to view 3 frames per second quite well. Yeah, this might not necessarily be exactly what we're looking for, but I'll try to figure some of this stuff out. But yeah, so basically we got some good amount of stuff mapped out, and we're starting to see exactly how the game will work later on. I got real hardware if you want to do some benchmarking. Galactic Discat, I appreciate that, man. I have my Palm Pilot like right behind me. Unfortunately, I left my cable at my house. I'm staying at my friend's house right now, and I'll just test in the morning or something. But I appreciate that, and I might be releasing this version of the game soon. For people who want to test it on their hardware and let me know how it goes. I have like 2 colored devices, and I would like to see how it runs on those. I found my 4-bit colored versions of my 4-bit and my colored version of the levels and tiles and stuff, and I would like to be able to slice those apart and throw those in here, but yeah, and see what that looks like on a colored unit. But for now, I think this is gonna suffice for the stream. I've had a lot of streams. A lot of people come, watch my stream tonight, off and on. Some people left. Some people said hey, but if you're still sticking with me, I appreciate that. Make sure where's it at? Underneath me, right here. My YouTube channel, my Twitch and stuff, all that. So if you're liking what you're seeing, please consider subscribing and following me. It lets me know that you're interested in these games and stuff like that. After I finish this Palm Pilot game, I have a few other games I want to work on. So Pi Badge and Pi Gamer, as well as like the Game Bueno and some other units that I haven't really gotten around to making games for yet. So yeah, I really appreciate that. All the support really helps me. But I think this will be it for the stream, and we'll go ahead and pick it back up on Sunday. But there might be a chance, like a 10 to 15% chance that I won't stream just because I'll be tired from moving, or maybe I'll like break my arm while moving or something crazy like that. So follow me on Twitter, which is right below me, and if there's anything that comes up, I'll post it there first. But other than that, 7:30 Central Standard Time, Texas time. And yeah, well, appreciate it, guys. I'm gonna go ahead and stop the stream. So.